you're looking at the assignment review. That is the QM assignment. Okay, so we are going to question 1. So the first question. So the first question here says a computer company so the first question, we're looking at grouping the data in the classes, where it says a company received a rush order for as many computers as could be shipped during a 6-week period. The company records provide the following daily shipments. Then we have the number of parameters here. 1, 2, 3. So in a nutshell, we are talking about the number, the sample size in this given question. The sample size is 42. Okay, so the sample size is 42. You can count them. This is 1, 2, 3, 4, 5, 6, 7. So the 7 multiplied by here we have the 6 of them. So our n is equal to 42. Now, when grouping the information, we have to find the value, the formula to use when grouping, because the question says group these daily shipment figures into a frequency distribution having suitable number of classes. So what happens here is that we know that our n is 42. So what goes on here is that we find the value of, using the formula we use here to group. When grouping, we use the formula. The formula to use here, it is okay, so we simply say our n, find the value of n. Again, I know our n is 42. So the formula to use is n greater or equal to 2 to the power k. So where k is the number of classes. So k is the number of classes. So we need to find the value of k that first exceeds the n. Our n is 42. So 42. So we have to find the value of n that first exceeds. So you have n here to be equal to n greater or equal to 2 to the power k. So we should find the value of k that first exceeds 42. So here we have to find this value, the value of k that will first exceed 42. So what we are simply saying now here is that our k should be the number that should first exceed 42. So when we say 2 to the power 5, an example, is equal to 32. Now, this 32, our n is 42. N is equal to 42. We need to find the value of k that when we raise 2 to that power should exceed 42. So find the value of k that will exceed 42. So find value of k that first exceed 42. So meaning when 2 to the power, when k is 5, it will be equal to 32. So 2 to the power 6. Okay. So 2 to the power 6 is 64. So this is 64. So meaning therefore our k is equal to 6 because 6 is the first number that exceeds 42. So 6 is the first number. So the first number that exceeds it. So first number that exceeds 42. Of course, there are other numbers. Even 7, 2 to the power 7 is also the number that exceeds 42, but it's the second number that exceeds 4. That exceeds this one is 128. So this is the second number that exceeds 42. So the first one is k. So therefore k is equal to 6. So we are simply saying that the value of k is equal to 6. So that is the first number that is exceeding 42. So meaning, first and foremost, we need to find the range. Our range is simply equal to highest measure. So highest measure, then minus the lowest measure. Minus what? The lowest measure. Okay, so lowest measure in the data set. So this is how we get to our range. So our range in this case here is equal to our highest measure is 87 minus 22. So our range is 65. How are we getting the range? So we can check from here. We find the range as 87 here and minus the 22, which is this one, the lowest measure. The highest is this one. Okay, so this is about how we are looking for this one to find the number of classes. So meaning, after this now, you can find the class width or the class interval. So the class width now, the class width is actually going to be the range, then you divide by the number of classes. The range you divide by the number of classes. This is how you find the class width. So the range, then we divide by number of classes. Okay. Okay, so this is how we find. So here we divide by number of classes. So this is the number of classes. Okay, so this is how we find the class width. So divide by number of classes. So meaning our range is 65. Then we divide by the number of classes. There were 6 here. So it will be 65 divided by 6 is 10.8. 10.833. So this is about 11. So number of classes is 11. All right, so this is about the finding the class width or class interval. So this is approximately 11. So we can start now counting. So we can just simply go for, okay, so we start counting now. So the first one, here we are required to group. Question says group these data shipment figures into a frequency distribution having suitable number of classes. Okay, so we just need to get down to this one. So what is important now that we need to do? We need to count, but the way we're going to do it, we'll simply start with the class width. So the class width is here. And then the frequency. Of course, we can even go for the relative frequency. Okay, so this is about what goes on. So from here, we had to start counting. So there's supposed to be 6 classes. So the first one we need to do is just to say we are starting at 22 as the lowest figure. So from 22, start counting from 22, including 22 itself. So we end on 32. Because the 11, the width is 11, starting from 22 itself. Then 33 will go to 43. And then from 44, we'll go to 54. Then from 55, we'll go to 65. Then 66, we'll go to 76. Then 77, we'll go to 87. So this is about the frequency distribution. So now, as we get to what we have on this one, we need to count how many numbers are from 22 to 32. So count them physically. You can count them manually from 22 to 32. So it's just a matter of counting. Okay, so from here, we can clearly see that we have this one. Okay, then we have this other one here. We have this one here. And then we have this one here. So you can see that there are 4. And this one, the frequency is 4. So this is how we are getting them. So the frequency is 4. But of course, the sum of frequency should give us 42. So meaning we need to go again from 33 to 43. 33 to 43, we count them 33 to 43. Okay. So manually, we continue counting like that. We found the figures. That's what is important in an example on counting, and especially on just understanding the interval. You count how many numbers are within this range and how many numbers are within this range going down. So we found numbers to be as follows. So here we had also 4. So counting manually from 33 to 43, we found that we had 4 numbers that were within this range. And then from 44 to 54, we had 9. So counting them manually, okay, we were 9, counting the numbers from within here. All right. So using the intervals. And then the sum of these ones came to 42. The relative frequency is just this number divided by the total, this number divided by the total, this number divided by the total to get the relative frequency. Okay, so this is on what we have concerning this presentation. So these figures came from here. Okay, so now this is about how this question was answered. The first one, counting the numbers physically or manually, we got these the relative frequency as can be seen above. So now we build up a little bit, we go into the other one. So this one is constructing the stem and leaf. Okay, construct the stem and leaf for the data. So these numbers are decimals. Okay, so we need to round up each of these numbers to appropriate numbers. So the first one is 14. So this one is rounding up to 14. This one is just 14 as well. This one is 15. This one is 15. So we are supposed to round up all these numbers, rounding up. 18.0 is just 18. 18.0 is just 18. 14.2 is just 14. So rounding up these numbers. So under the stem and leaf, okay, on the stem and leaf. So on this one, for relative frequency I mentioned is 4 divided by 42. Just an example on that one. 4 divided by 42 is actually 2 over 21. So, yeah. Then getting to the stem and leaf plot. So the stem and leaf. So under this, you simply say the stem on this end, and then the leaf on this end. So you need to say, of course, that 13, we have 1. So 13, we have 1 when we are rounding up. So getting down to this one, we have the first one is 12.8, which will be 13. 14.8 is 15. 15, this is 19. This is one you can't round up. It's also 19. So all these figures, we're supposed to rounding up to get the appropriate numbers, the whole numbers. So rounding up these ones, not taking them the way they are. So we counted 13 was 1. So 13 was 1. The 14, we had about, there were 10. So 14, you write 14, 1, 2, 3, 4, 5, 6, 7, 8, 9, 10. Meaning this is 14. The 13 is just 1. This is 13. 14, we have 14, which is 1, 2, 3, 4, 5, 6, 7, 8, 9, 10. Is it because of rounding up? We were rounding up these numbers to the whole numbers, and we count how many they are. So 13 was 1. 14, they were 10. Well, this one is 14, 14. Okay. And then, of course, we had this one is also 14. This one is 14. This one 14, 14, 14. So this is 14, which is 1. An example 1, 2, 14. And this is also 3, 4, 5, 6, 7, 8, 9. All right, so we had those 14, 14. So counting them manually, this is how we are getting these ones. Okay. So just have to take time to count. Okay. So this is how, and then there's another 14 here, which is making 10. So 14, they were 10. Then 15, they were 18. So if you count manually here, the 15, they were 18. So we put 15, 1, 2, 3, 4, 5, 6, 7, 8, 9, 10, 11, 12, 13, 14, 15, 16, 17, 18. Then 16, there were 5. 16, there were 5. When counting them from there, 16, there were 5. 17, there were 4. After rounding them up, after rounding off those ones, and 18, there were 5. So 18 were 5. 19, there were 2. So this is about, so here we can say 13, the frequency. So you can say this is our X. The frequency was 1. 14, the frequency 10. Then 15, frequency is 18. 16, The frequency is 5, 17. The frequency is 4, 18. The frequency is 5, 19. The frequency is 2. So as we add those ones, okay, so this is about okay, so this is about what goes on concerning the values. Okay, so that one should give us 42. Okay. We can count them manually. We can find out how many figures we have gotten. Because it's just about from here that we are counting. Okay, so the 18, the 15, they were 1, 2, 3, 4, 5, 6, 7, 8, 9, 10, 10, 11, 12, 13, 14, 15, 16. Okay, so 16, 17, 18. So there were 18. So meaning then the other ones, okay, so 14, 13 was 1. So this is just about the way to go. So we have that one there. Okay, so 1 plus 10. So this is the, all right, 1 plus 10 plus 18 plus 5 plus 4 plus 5 plus 2. So it's giving us the total value should give us 42 just on counting. There's just on counting technique. So the total of that should give us 42 to just on counting. That needs to be considered just on counting and rounding those figures up. So it's just a matter of counting properly. So this is how we are getting down to this stem and leaf. Okay, so we are getting down to the stem and leaf in this way. So it's just a matter of counting these values, all of them properly. Then we get to the stem and leaf this way. All right. So 13 was 1. This is 1. 14 they were these ones. 15 were these. And then 16, these ones. So these are subject to confirmation. We need to counter check there. The most important thing to do is to round up each of these figures here, and the total should give us the number. So the answer is, will be 45. So 9, okay, 9 times 5 will give us 45. So the sum of these ones should be our n equal to 45. Okay, so here n is 45. So as we add these ones, we are simply saying that our n is 45. So summation of f should give us 45 variables. So this is about what we expect on this one. So getting down to the other one. So an examination was held to decide awarding of a scholarship. The marks obtained by 3 candidates out of 100 are given below. So we have the students there, ABC. Okay, and then those are results. So that what happens here is that you need to find the weight there when from this one. Okay, so when you have scored, you've told us here, when you have scored an A, simply means it's a 4, the weight is 4. So mathematically, when you get an A, the weight here is 4. Then the other weights we had, if we had the 4, you had the 3, the 2, and the 1 from the weights. So meaning that we have to now multiply these ones by the respective. So mathematics, so weighted mean for A, okay? So it was weighted mean for A, we had to multiply 0.4 by 60 from the way we have been given here from by 60 here. So for A, we had the 60 there. Then we had the other ones. So this was representing our A. This one was representing a B. And then this one, it was actually our C. So calculating the weighted mean to award the scholarship. So for A, the weighted mean was that one, which was giving us weighted was multiplying each of these ones using the weights. Okay, so meaning you got a 60.3. Then for student B, this was student, this is student A, student B, okay, 59.4, multiplying this by the, if we want to divide by these aspects, 59.4. Then for the other one, we are getting down to 61.8. So these are this is what we have on the weighted mean to award the scholarship. We've gotten these values. All right, so this is for student A, student B, and student C. All right, so now we are, okay, getting down to the other one now. Okay, so the other parameter that we need to look at is on D. So part D of this problem, where it says a management consultancy or consulting. Okay, so it says a management consulting firm has 4 types of professionals on its staff: managing consultants, the senior associates, the field staff, and office staff. The average rates charged to consulting clients for work of each professional categories are 3,150 per hour. This one, it was 1,680 per hour. Then the other one is 1,260 per hour. Then the other one is 630 per hour, respectively, meaning for the managing consultants, the senior associates, the field staff, and we have office staff. So this is about the allocation. So now the office records indicate the following number of hours billed last year. So 8,000 were hours billed. Then 14,000 were hours billed again here. 24,000 hours billed and the other one respectively. So meaning we have to find the total. So this was a cost per hour. 3150 to the cost per hour. So we have to sort out this, multiply these two to get the total of that, multiply this to get this total. You multiply this one to get the total. Okay, then of course we are multiplying this other one as well. Okay, to get this total. So meaning these are total rates. So we can find the average billing rate is what they're looking for. Want to find the average billing rate, which means you add these ones, divide by the total hours. Okay, these are the total hours. So these are total hours that we have. So meaning we add all these ones, we are getting this amount. So the average billing rate will be, this one is $81,000. So $81,000 is what we have here. So we are getting average billing rate is 124. This is per hour. So average billing, the billing rate is per hour. You have gotten that. So this is on question number. Okay, that is on question number 2D. So we can get down to the other question now. The question E. Question E, it has kilometers and number of cars, which is the frequency. So we can use this one to find the cumulative frequency. So this is the sum of frequencies. So sum of frequency. So what happens here is that we need to get down to this one. So the summation is giving us 40 here. So the question required that we calculate from here the all give. So from here we need to find the all give. The question was asking us to find the all give from here. Okay, so finding the all give. So we're getting down to the all give. We are simply graphing the cumulative frequency. So again to the midpoint. So this one is this one on 4. So this one getting down on 4 is between 100 to 110. 100 to 110 is a 4 there. So we can join from the origin. See the origin. Okay, so this is the origin. So using the cumulative frequency. So using the cumulative frequency, you are graphing against this and the frequency, cumulative frequency. So this one was coming down to 0. It was here, the mid-2. So here, this one, that one there, you're going for the mid-2. So I'm getting down to this one. We are graphing using the cumulative frequency. So this is the all give. So this one is the all give. Okay, which is using the cumulative frequency. Now from here, we can go to the other question saying what a percentage for within that. Expect to graph the number of cars which cover less than 165 km. So these are kilometers. So those ones that covered, less than 165, 165 is here. So less than 165. Okay, so meaning number of cars covered less than 165, you can start aggregating. So it's a 4 from here. Okay, so number of cars that covered less than 165. Okay, we can estimate 165 is he should be here. Now less than is coming down from here, getting down. Okay, so number of cars that covered less than 165. So we can even get from here less than 165. 150 to 160, so less than 165. We are simply adding these ones up here. Okay, so the number of cars that cover less than 165, we can get here. So it's 4 plus 0 plus 14 plus 25 plus 33. Okay, so meaning we are getting the cumulative number is 87. That's the cumulative number of cars. Okay. Then getting down to the other question, is they're saying find the Q1, Q2, and the Q3. So Q1 is the lower quartile, Q2 is the upper quartile. So our Q1 is 1 over 4 times the summation of F, which is the 10th. Okay, so you're simply saying our Q1 from the graph. So from our graph here, the Q1, it is 10. So this 10, we check the cumulative frequency where it is. So 10 is here. So it's falling on 1/3. So from here, we can locate from the graph. As we come down, we are getting number of cars as 1/3. So they are simply saying the Q1 is 1/3 kilometers. Then here, you will say it's 20 because the median. So this is the median. So our median is 1 over 2 by 40, which is 20. So we check from here, the 20 is getting down here. So we are simply getting to this point. Then the other one is upper quartile. So upper quartile. So what we are simply saying for upper quartile is we have to say 30. So 30 is here, getting down to this point is 150 kilometers. So this is how this question was answered. We can get to question 2 now. Question 2, it says from a computer tally on employee record, the personnel manager of a large manufacturing firm finds that 15% employees are supervisors and 25% of employees are college graduates. He also discovered that 55% are both supervisors and college graduates. Suppose an employee is selected at random from the firm's personnel record. What's the probability of selecting a person who is both a college graduate and supervisor? It's probability of C intersection S, which has been given. So meaning that probability, let S represent probability of S is 0.15, probability of supervisor, which is 0.15, And then the college graduates, so probability of college is 0.2, supervisor and college graduate. So probability of this is 0. That is probability of college graduate and supervisor. Then the other one says you're selecting a person who is neither a supervisor nor college graduate, who is neither supervisor or no college graduate. So these are complements. So it's 1 man's probability of both being college graduate and supervisor. So the answer is 0.95. So this is it. What goes on? So this is the probability of neither college graduate nor a supervisor. You have 0.95. All right, now getting down to this joint probability for part B. Part B, we are getting to the joint probability. So for the joint probability, we are simply looking at the total N is 2000. That's our N. Our N is 2000. So we need to find the probability that, so 2000 randomly selected adults were asked whether or not they ever shopped on the internet. The following table gives a two-way classification of the responses. So they have shopped and have never shopped. So the probability, so has never shopped on the internet, so has never shopped, meaning whether he was a male or female and he has never shopped. So this one is 700 divided by 2000. Then we have the other one is 500 divided by 2000. This one divided by 2000. To find even this one divided by 2000 to get the joint probability. So the joint probability from here. So joint probability table is given by these ones. When we divide each of these ones, so we are getting out of the 2000 is this. So the total probability for this is giving us 1. So probability is 0.25 plus 0.35, then plus 0.15 plus 0.25. So it's giving us probability to go to 1. So the probability that he has never shopped, okay, has never shopped. So it's either male or female, but he has never shopped on the internet. So its probability is either a male, which is this one, or the female, but has never shopped. So meaning it's 0.35 for male. So it's a male has never shopped, or a female has never shopped. So it's either, probability that he has never shopped means it's either a male has never shopped or a female has never shopped. So probability of either is addition. Probability of either is addition. So we are simply saying probability of either is addition. Okay, so this is what we are simply saying. So we're simply saying now, when we getting down to this one, so we are simply now saying this probability that has never shopped, so it's 0.6. Probability that is male, so it is probability that is male simply means it's male, but it would be male, he has shopped or he has not shopped, but he's male. So it's either he has shopped or he hasn't shopped, but he's male, where you are simply getting the 0.6 is male. He has shopped or he has not shopped, but is male. So it's giving us the same 0.6. Probability that he has shopped given that is female. He has shopped given that is female. So it's a conditional probability. So we're simply saying probability of shopping given that is female is equal to probability of shopping given intersection female, then over probability of female. So this is it, or what happens. So this is the intersection, and probability of female is 0.4. Okay, so probability of female, this is F, this is M, 0.4. So this is what is happening. Then the other one is male, given that he has shopped. So is male, given that he has shopped. Male, given that is shopped. So meaning that probability of M intersection S or probability of S. So this is about what we actually getting down to. So events independent. So testing for independent events. Okay, so we are being asked, are the events, okay, are events mutually exclusive? So mutually exclusive, they have no intersection set. So yes, events male and female are mutually exclusive because they have no intersection set, but have only a union set. So mutually exclusive events have no intersection set. Mutually exclusive events have no intersection set. But union set. But they have union set. All right, so this is about, so meaning that if these events are mutually exclusive, they cannot be independent. So testing for independent events, if events are independent, then probability of female and stopped is 0.15. Probability of female is 0.4 from here. Probability of female is 0.4. And then the probability of male is 0.6. So meaning that the intersection of female and the has shopped is 0.15. Male and the has shopped is 0.15, which should be equal to, okay, so probability of female and shopped 0.15, where we can carry out a test. Okay, so probability of a female intersection is stopped is equal to probability of female multiplied by probability of stopped, or we can say shopping. So I'm saying this is a probability of shopping, which is if we're taking one at a time, probability of female is 0.4, and then probability that is female and at shopped is 0.15. This one. So the probability that he has shopped is 0.14, and probability that is female is 0.4. So meaning that testing for independent here, we can multiply. So when events are independent, probability that female and they are shopped here, okay, he has shopped is 0.15. probability that is female and the shopped is 0.15, we can carry out a test to multiply. If these will reconcile, then events would have been independent. Now here, these two, they are not equal. So they are not equal. And we are simply saying events female and he has shopped. So this is the shopping. Female and he has shopped are not independent since these two are not equalizing. Then the last question here, we have to construct a probability distribution for this one. So we are dividing this by 1/3 to get the probability value. This one by 1/3 to get the probability. So the value of the probability, we are dividing this by the frequency. So we got, these are the probability values, construct a probability distribution. This is the probability distribution. Okay, for the number of effective tires on the limo. Now from here, we want to find the probability of 3 less or equal to x less 7. So x less 7. So x less 7, we are simply saying 3 unless, okay, x is greater or equal to 3. So 3 getting down to 7. So we are getting down from 3 unless 7. So it's here. These are the ones. 3 unless 7. So this is it. The probability to consider on this one. So please, this is what goes on as we look at the question on the probability, how we obtained this, and how we started adding from here up to the other one. So our probability is giving us, okay. So we are getting this, and then the other one was probability that x is greater 2, x greater 2. So we are getting simply saying this one up to the far end. So x greater 2 is from 0.27, 0.16, 0.06, 0.01, 00, and 00. So x greater 2 is 0.5 as well. So this is about the way this assignment was prepared. So just a matter of having time to go through. If there are any issues, we'll be able to clarify them. And if you have any other challenge, you need to find out where the problem is, then we can still explain again. So just have time to go through this assignment review. All right. So we can end here for now. I'm sure this video will be shared to you. All right, then. So operational research, these are the topics that are found in operational research. So we have these 6 topics. Okay, of course there are 7. So we have decision theory. Okay, we have this other one. The first one is linear programming. And then we also have simulation. Okay, so we're going to do a topic. We'll start with linear programming. So these are the topics that are covered in operational research. Okay, so what is important is just to understand each of these topics in detail so that you see what is going on. Okay. All right, so we, this is the list. So you can start with the linear programming. So linear programming. Then the linear programming, the steps involved. Okay, so the steps that are involved here. We have number one is a LP formulation. So we have LP formula. Okay, so LP formulation. Then the other one, solving an LP problem. Solving an LP problem. Okay, using either number one is graphical method. Then we have also using the other one is simplex method. Okay, so and then also we have formulating the, okay, so we have now formulating the dual problem. Formulating dual problem. Okay, so these are the ones that we actually consider. So this is about what goes on. Now, the formulating the LP problem comes from the question itself. All right, so this is what goes on. All right, so we are getting down to, so we can get to an example now on how to do the LP formulation. Okay, so on this LP formulation, we have the information from here. We can look at this question, can get a question from here on how you do LP formulation. Okay, so we can look at this question. So in this one, it says the finished product of a Kanban has a requirement that it must weigh at least 150 kg. So it must weigh at least 150 kg. So here there's a term at least. So meaning that 150 kg is the least amount that it can weigh. So 150 is the least. So 150 kg is the smallest. Okay, so this is about what we have. Now, there is one thing that we need to know. So there are the two raw materials used in the manufacture of this product. The two raw materials used in the manufacture of this product are A, with a cost of 14 kwacha per unit, and B, the cost is 16 kwacha per unit. A is 4 kwacha per unit. B is 16 kwacha per unit. Okay, this is about what we are having here. So we have our A and our B. Okay. Cost per unit. So our cost per unit is 4 kwacha per unit. This is 16 per unit. So they haven't told us the total cost, which is here. Okay, so they are variable. Okay, so we should have the variable here. Okay, so we're going to have that. So meaning, if the total cost is not given, that is the objective function does not cost. Meaning A, the cost is 4 kwacha per unit. B is 16 kwacha per unit, and it's open. We don't know how much the total cost was there. Then each unit of A weighs, that is 10 kg. Unit of A is weighing 10 kg. Unit of B weighing 20 kg. So A is 10 kg, B is, so when we come to A, so our weighing now, so weighing for this one is 10 kg. Then B is weighing 20 kg. So, and then the list for the kgs is 150, meaning that whatever we should have here should be greater or equal to 150 is the least. 150 kg. All right, so this is what's going to open. So what next? They are saying at least 28 units of B and no more than 40 units of A. At least 20 units of B, 20 units of B, and okay, no more than 40 units of A. No more than 40 units of A. So let us now continue. We are simply saying at least 40 units of B. Units. Okay, so units. So we are simply saying units. At least 28 units of B. 28 units of B. So at least 28 units of B. Okay, so twist one is a list, at least 28 units of B and no more than 40 units of A. Okay. So what we are simply saying is that this one has no boundary. Okay. So let A represent x1. So let A be represented by our x1. So A represent x1 and B represent x2. So A is representing x1 and B presenting x2. Okay, so now what it means here is that they are saying determine how much of each type of raw material should be used for each unit of finished product to minimize cost. The objective of every organization is to minimize the cost. So meaning we are going to use the same information here to say this one is x1, then this one is x2. So what goes on here is that we are going to say our objective function. So we need to come up with objective function. And for this one, what we are simply saying is that it will be minimize Z is equal to, so minimize Z equal to, okay, so minimize Z equal to 4 multiplied by x1. So the total cost of x1, we know, so x representing units of A. So these are units of A. So meaning it will be 4x1. So it will be 4x1 plus 16x2. Then subject to, okay, 4x1, 16x2. That's a total cost of this one. This is the objective function because it has no constraint. The objective function has no constraint. It has no budget allocation. Okay, so objective function has no constraint. Objective function has no constraint. Okay, it has no constraint, meaning it has no boundary. So minimize Z is equal to 4x1 plus 16x2 subject to. Then we come here and say 10 multiplied by x1 is 10x1. So it will be 10x1. So it will be 10x1 plus 20x2 greater or equal to 150. All right. 10x1 plus 20x2 greater or equal to 150. then we are simply saying not more than 40 units of A, not more than 40 units of A. What that statement will be, not more than 40 units of A, not more than 40 units of A. So meaning, and A is representing X1. So meaning that this one is going to be X1 should be less or equal to 40. Okay, no more than 40, no more than 40 units of A, no more than 40 units A, 40 units of A, at least 150 units, at least 150 kilometers, that is 150 kgs of both materials. So what this one is about to see, this one is a constraint. So this one is a constraint because it has a boundary of this 150. This is also constraint. So constraint 2, constraint 1. So and then the other one, at least 28 units of B. So B is X2 greater or equal to 28. So at least 28 units. So this is constraint 3. So constraint 3. So now the other thing to take note is that X and Y, X1 and X2 should be greater or equal to 0. X1 and X2 should be greater or equal to 0. So this is our AOP formulation that we are actually looking at. So this is our AOP formulation. So according to the question, they are saying, determine how much of each type of raw material should be used for each of the finished products in order to minimize the cost. We have our 6 marks here. So it's just about formulating the AOP problem. All right. So our AOP has been sorted out. So meaning that we need to now get into solving of an AOP. The reason why it says minimize, it's because it was a cost. So this is subject to. ST simply means subject to. So this is about, this is the most critical part of linear programming. Solving may not be an issue, but you can be solving the problem that you have actually sorted out and the problem that you have formulated. If it's a wrong problem, LP formulation, if it's not the correct one, then you'll be solving the wrong thing. So that's why the formulation should be okay. So now, what are we saying now? We come on to solving the LP. Solving the LP problem. So here it was mute, but we can use a graphical method. So graphical method. Okay. So what goes on here is that we can do this way. This is our x2. And then this one is our x1. So the first one, table of values. So in table of values, okay, we can start with this one, 10 x1 plus 20 x2 equal to 150. So we can say our x1 and x2. If x1 is 0, our x2 will be 150 divided by 20, which will be 7.5. We are substituting these figures in this expression. If x2 is 0, this one will be 150 divided by 10, which will be 15. So it will be 0, 7.5. Okay. So we can actually come up with 10. Okay. Or we can simply say 5. So this is 5. So this is, let's it be a 5. 10, 15, 20, 25, and maybe end up 30. So this one also can be 5, 10, 15, 20, 25. Just find out that as well. So what happens now? 0.7.5 at this point, and then 15,0 is at this point. So what goes on here is that you need to draw a line through this point. So you give it a name. You say this is 10 x1 plus 20 x2 greater or equal to 150. So greater or equal to 150, you are shading up here. Okay. We're shading up. We're shading this side. Then what next? We have gotten the other one, which is the x1 less or equal to 40. So it will be our x1 is equal to 40. So draw a line at x1. Draw a line where x is equal to 1. They'll get to 40. So 40, so 35, 40. Okay. 35 and 40. So the line is actually somewhere just here. So this is it. X1 less or equal to 40. So the shading will come all the way this side. All right. So this is it where the shading comes in. Okay, so the shading will come there. This line, of course, can go up there. And then now there's another one where we are simply saying we have x2 greater or equal to 28. X2 greater or equal to 28. So draw a line where x2 is equal to 28. So it is somewhere here. So the line is up here. Okay. So this is where the line goes up. So the visible region is a region where all the shadings from all the lines converge. Okay, the visible region is a region where all the lines from all the shadings converge. So this line comes here. So this is our visible region, FR. It's a region where all the shadings converge. Of course, this other line here, it is our x2. Okay, so this one, when you're cutting x2 at 0, x2 greater or equal to 0, we are shading like this as well for this line. So the shading has come all the way up here. This is where the visible region is. So the corner points of the visible region, we have, this is 40,28. This point is 40,28. So this is 40,28. So this is a comma here. This point is 0,28. So this is at this point here. That is 0,28, 40,28. This is a visible region. Okay, because this is the region where all the shadings converge. FR is a visible region. It's a region where all the shadings converge. It's called visible region. So it's a region where all shadings converge. So it's a region where all points or drawings or lines come together. So the first one is 0.28. And of course, we have 40.28. And then we have our Z is equal to 4x1 plus 16x2. So our Z here is actually going to be 4 on 0, then plus 16 on 28. You can get the answer here. Then here, our Z is equal to 4 on 40, then plus 16 on 28. So we can get answers here. So the first one is 448. Then the other one is 608. So the cost minimization, so under cost minimization, we are simply saying our x1 is equal to 0, x2 is equal to 28, and our z is actually equal to 448 minimum. We are talking about minimum. So this is it. What goes on this one here. So this is how we have sorted out this question. So it's very, very important to know how to formulate. Solving is not an issue, but just knowing how to get to what we need. So even in formulation of this part B, we can just look at how we can formulate this. Of course, the graphical method, we can only use it when you have two variables, only x1 and x2. So graphical, you applies. So on the graphical, only use it. So graphical method, okay, only use it if we only two variables. That is x and y variable, or x1 and x2 variable. This is about what we consider, please. Okay, so formulating of an LP and then solving it is another thing. All right, so that's what goes on. Okay, so all right, so this is it about what goes on. So we can have another example too here that you can try. Sometimes when they give us, sometimes they'll give you to say under the graph corner, which can be done as the another example. So maximize z is equal to, okay, 3x1 plus 10x2 subject to 2x1, all right, then plus 4x2 less or equal to 16. Yeah, let's go to 16. All right. And then, so that is just what we have. Then x1 plus x2 less or equal to 6. Then x1 okay, x1 plus x1 comma x2. So we have now just these two, constraint 1, constraint 2, and then you simply say x1 and x2 greater or equal to 0. All right, so we have to graph those ones. We need to graph them. And how do we graph? We'll simply come up with our x and y. So 2x1 plus 4x2 is equal to 16. So a table of values is important. X1 and x2. If this is 0, this will be 4. If this will be 0, this will be 8. So we can have 2, 4, 6, 8, 10, 12, 14, 16, 2, 4, 6, 8, 10, 12, 14, 16. This one we are simply saying is our x1. Okay. And you can say 1, 2, 3, 4, 5, 6, 7, 8. 1, 2, 3, 4, 5, 6, 7, 8. This is our x2. So of course we can say 0,4. So 0,4 is here. 8,0 is at this point. So you can draw a line through these points, and then simply say this is it. 2x1 plus 4x2 less or equal to 16. So you shade down here. So we are shading. Then the other one is x1 plus x2 because it's 6 here. So this is just about how you present using the graphical way. If it is 0, it will be 6. And then if this one will be 0, this one will be 6. So it will be at this point and this point. So you can use a graph paper to actually, and use a rule to draw these points. So this is the point of intersection, and this is our x1 plus x2 let's go to 6. Then this one is x1 greater or equal to 0. Okay, so this is x1 greater or equal to 0. You shade like this. And then this one is x2 greater or equal to 0, where we're cutting x2 at this point. So this is the feasible region, this one here. So the feasible region is this region where all the shadings converge, where they come together. So you have this point here, this one, this one, this one. So this is our feasible region. So we can solve these two equations simultaneously to find this point here. So far, the corner points are 0,4 and 6,0. So far, we have 0,4. And then what else? 6,0. These are what we call corner points. They are called corner points. So please take note of these ones. Then we can substitute our z, but of course we're finding another one. Okay, on our z was okay, it was 3x1 plus 10x2. 3x1 plus 10x2, z x1 plus 10x2. So meaning it will be 3 on 0 as we substitute, then plus 10 on 4, where we're getting 40. Then the other one is z is equal to 3 on 6 plus 10 on 0, which is equal to 18. Then we can sort out these two. using simultaneous equation. So solving. Okay, so solving now. The other one is 2x1 plus 4x2 is equal to 16. Then x1 plus x2 equals 4. So we can eliminate what? So we can eliminate x1. So we swap it to here, and the one, make one of these to have a negative, we can multiply. Oh, somebody work for me. So -2 All right, so this is about what we have. So okay, so we can get -2x1 minus 4x2, then minus 16 is equal to minus 16. Then this other one will be 2x1 plus 2x2 equal to 8. So this one will give us -2x2 equal to -8 over -2 over -2. Our x is equal to 4, x1 equal to 4. And then, of course, this is okay, it was a 6 there, so we're getting to this other one. So meaning this one was a 6 in the original question. This is giving us 12. So as we add here to be -4, which will be our x, x1, x2 is actually equal to 2. x2 is equal to 2. And then x1 plus x2 equals to 6. x1 plus 4 equals to 6. x1 is equal to 6 minus 4. x1 is equal to 2. So meaning we can find the corner points of the feasible region. Okay, so the corner points from there, we are simply now substituting in this one, which is the 4,2. And then our z actually going to be 3 on 4 plus 10 on 2. So it will giving us 32. So therefore, optimal solution, okay, is given by x1 is equal to 0, x2 is equal to 4 and z is equal to 40. So we can, this is what is going to happen here. So this is about what we have gotten. So we can end here for now.